Hello my dear students, welcome back to NEET World. So in the last sessions we were started discussing about thermodynamics, right now? Yeah. So in thermodynamics, what is the use of thermodynamics I told you? Yeah, we can able to find the heat energy changes associated with a given chemical or a physical process or a physical or chemical reaction, right now. So during any reaction, how much amount of heat energy is released, absorbed, whether a particular reaction is possible or not, whether it can take place spontaneously or not, like whether the process takes place naturally or not. All these can be explained using thermodynamics, okay, right. And then next, what are the suitable conditions? For example, if I use the reaction, if I do a reaction at 25 degrees Celsius, whether that reaction happens or not. What if I increase the 25 degrees to 100 degrees, whether the reaction is increased, rate of reaction, whether the product is formed easier or it will be not taking any reaction. These kind of scenarios can be explained using our thermodynamics chapter. This all basic understanding were discussed in the last session, right now. And then next I have told you about something called thermodynamic processes, thermodynamic properties. Thermodynamic properties are two types I told you. One is intensive property and the next extensive property. What do we mean by intensive property? I told you the quantity dependent properties are quantity independent properties are intensive, quantity dependent properties are extensive. Simple. Once again I just want to repeat them because those are important parameters or properties to be remembered, okay. First thing is intensive, I told you, intensive, and the next extensive. These are the two words I have given in the last class. Yeah. So let me explain that. Okay. So here intensive property, the word itself saying intensive, just remember intensive is independent. Independent of what? Independent of mass, independent of quantity. Quantity independent properties are called intensive properties. Quantity independent properties. Independent of quantity, how much quantity we have. Next one I told you extensive. These are quantity dependent. Quantity dependent. So it means what is this quantity dependent and independent? Okay, for example, if you see, we are measuring the liquid quantity in terms of volumes right now, like half liter, 1 liter quantity, like that we will be measuring. See, this bottle considered as a 1 liter volume. How much? 1 liter volume, 1000 ml volume. Okay, now volume is an extensive property I am saying. Why it is an extensive property? Because if I fill water only half of this bottle, it means our quantity is occupying from bottom to only half of this container right now. So then you can say this is a half liter, like 500 ml. If I fill it completely, you are saying it is 1 liter. So it means volume, that expressions for volume is liters, half liter, like this we are expressing now. So this volume is a volume is a property which depends on quantity of the substance. If more quantity, more volume. Okay, if less quantity, less volume. So it means volume is a property depending on quantity of substance. Similarly, weight also depends on quantities of the matter. Okay, if I take matter, only this much quantity of matter I am taking in a bowl. Okay, now I am increasing the quantity of matter here. Do they have same mass? Do they have same weight? No, right? So this will be having less weight, this will be having more weight. So like this, the quantity dependent properties are called extensive properties. If they are not depending on the quantity, then you can say them as intensive properties. Now let us understand here. For example, water, we are heating it to 100 degrees and we get to know that water get vaporizes, that is the boiling point of water is 100 degrees Celsius. So now if you observe this boiling point temperature, whatever we are discussing, so boiling point of water is same whether you take 10 drops of water or 10 ml of water or 1 liter of water. So if you heat it to 100 degrees, yeah, it will convert from liquid to vapor phase at this 100 degrees Celsius only. So whether you take 100 ml, 10 ml, no matter, it doesn't depending on the matter of the container. What it is depending? It is not depending on the quantity of the matter. It is just depending on what type of matter it is. That's it. So it is independent of quantity of matter. Then you can say it as intensive properties. So all these melting points, boiling points, okay, freezing points, the next refractive index, viscosity, all these are examples of intensive properties. Okay, these discussion were done in the last class. That's why I just want to give you a repetition of the same thing for the first 5 minutes. Okay, right. Let's move forward. Yeah, let me check anyone in the comment box. Yeah, so students who are in live session, those who are watching this session either in the live or recorded version, no issues. If you have any confusion in any of these discussions, you mention your doubt and the particular time period in the comment box. Then I will recheck that and I will explain you in the upcoming sessions if you really are looking for it. Okay, right. Then next here, this is done. Today let us discuss, yeah, these are the examples I told you for intensive properties and next extensive properties. Okay, right. So today we will be discussing about zeroth law of thermodynamics. So what do we mean by zeroth law of thermodynamics? So this is nothing but zeroth law. So why they are mentioned it as zeroth law? Because first law is proposed. After proposing first law and second laws, they got to know there is something fundamental we are missing before this first and second law. Then they got to know there is something called a very basic fundamental theorem or basic law. Then they have mentioned it as zeroth law, because this is zeroth law is very fundamental than this first and second law. That's why it is mentioned as a zeroth law of thermodynamics. So what this zeroth law of thermodynamics says? Once read the statements, it states that if a body A, okay, if a body A, let us say if a body A here we have, okay, A is in thermal equilibrium with body B. Okay, let us divide this container into 3 equal halves. So this is body B, let us say. Okay, so if a body A is in thermal equilibrium with body B, okay, so these are in thermal equilibrium. Okay, it means temperature of A is equals to temperature of B. Okay, in thermal equilibrium with B. Now the body B is in thermal equilibrium with body C. Okay, and this here we have a C. Okay, these are also in equilibrium with each other. Which equilibrium? Thermal equilibrium. T is of C is equals to temperature of B. Then the body AB and AC must be in thermal equilibrium. It is very simple. See, I have 3 bodies here. Once again I am redrawing this. You just observe what I am explaining. See, we have a container which is divided into 3 compartments. Okay, now here compartment A, compartment B and compartment C you can say, or system A, B, C you can say. Here system A and C are thermally insulated. Thermally insulated, it means what? They cannot exchange their heats directly through this wall. So this is insulated wall or isolated wall you can say. Okay, thermally insulated. But A can exchange heat with B. This is just like a closed system. Okay, so it means temperature can transform from A to B and B to A. So that is TA is equals to TB. Temperature of A is equals to temperature of B. We can say here. Okay, similarly B can also transfer or exchange its heat with C. So what I can say here? Temperature of C, it can be equals to temperature of B. So it means they can also exist in the thermal equilibrium with each other. Okay, now what this thermodynamic zeroth law says is, yeah, when AB are in thermal equilibrium and CB are in thermal equilibrium, from these 2 statements we can say that AC are also in thermal equilibrium with each other. That is, temperature of A is equals to B and B is equals to C. From these 2 we can say temperature of A is equals to temperature of C. That is what the basic zeroth law of thermodynamics. It's very basic. You might got what I am explaining here. Okay, so finally what we can say? Temperature of A is equals to temperature of B, which is equals to temperature of C. So this is what zeroth law says. Okay, right. So this is just says about heat flows and maintains thermal equilibrium with each other. Whenever you kept a hot body beside a cold body. What happens? Heat exchange from hot body to cold body, and they will attain the equilibrium. That means the same temperature will be maintained in both of the containers which are in contact with each other. Okay, right. Next, first law of thermodynamics. Okay, so what is this first law of thermodynamics? Very important to understand this, because while solving the questions it will be useful. Okay, so when I explaining mole concept, if you remember, I told you about law of conservation of mass. What I explained? Law of conservation of mass. It means during a chemical reaction, the amount of mass that is present at the reactant side will be equals to amount of mass present at the product side finally in a reaction. This is what we discussed during the law of conservation of mass. Okay, now here first law of thermodynamics says about law of conservation of energy. What is that? Conservation of energy, because thermodynamics deals with what? Energy changes, right now. So first law of thermodynamics says about law of conservation of energy. So what does it mean? During any physical or chemical process, energy can neither be created or nor be destroyed, but it can be converted from one form to another form. It means chemical energy converted into electrical energy, or electrical energy to mechanical energy to chemical. Like this, we can convert from one form to another form, but we cannot create them newly. That is what the first law of thermodynamics says. Okay, so once read the definitions. Energy can neither be created nor be destroyed. It can only be transformed or transferred or converted from one form to another form. It means the total energy of the universe, remains constant. Okay, so whatever the energy for this universe it is there, that will remains constant within that universe, because everything is included within the universe now. So one form of energy can be converted into another form, and another form to one more other forms. Like this we may see the transformations, but total energy of the universe remains constant. That is what the first law of thermodynamics says. Okay, now look at this. The total energy of universe remains constant, which is expressed as a sum of energies of system and its surroundings. It means what I told you, universe energy will remains constant, I told you. So energy of universe will be equals to what you can say, energy of system plus energy of surroundings. Why we are writing like this? Because we know surroundings plus system all together considered as universe. What is mean by universe? It is the total things, that is system plus surroundings is called universe. So energy of universe will be equals to system energy plus surrounding energy. So here what you can say is energy can be exchanged from surroundings to system or system to surrounding, or sometimes there may not be any exchange of energies also. Okay, if there is no exchange of energies, we can say isolated system it is. Okay, yeah, if there is any exchange is possible, then we can say it might be having separated with a closed system or might be an open system. Okay, you can say there as a diathermic wall. In other cases it is isolated system. Okay, insulated substance. Okay, so container. Okay, like that you can understand in the basic terms. Okay, up to here it is clear now? Yeah, someone in the comment box. Yeah, good morning Seema Begum. It is law of conservation of energy. Yeah, perfect. It's law of conservation of energy. Yes, clear now? అర్థమైంది కదా అందరికీ? Yeah, let's move forward. Yeah, see, now we have studied about first law of thermodynamics now. So there is a mathematical equation to represent this first law of thermodynamics. Okay, listen, this very important for your problem solving purpose. Okay, numerical solving purpose. Okay, and remember from now onwards, whenever you are preparing for any competitive exams, like మీరు JEE NEET exams కి ప్రిపేర్ అవుతున్నారు కదా, so for these competitive exams, here understanding theory is important, but that not sufficient. Understanding theory is important and applying it while solving the questions is most important, because in the exam they will be asking the numerical based questions. You have to be ready to solve those questions. Just by understanding concept, I mean theory, you are going for exam means it won't work. You need to solve the questions also. Okay, right. Let us start how we can expect questions on first law of thermodynamics. Okay, see, let us say this is a system. Every system means there is some chemical substance inside it. Okay, let us say this is called system. So this chemical substance might be having energy. That energy is called U1 energy. So U1 means energy of that system. Okay, to this I am supplying Q amount of heat. To this system what I am supplying? Q amount of heat. Then its energy becomes Q plus U1. How much energy it becomes? Q plus U1. Okay, now from this Q plus U1, again what I am doing is, on this system again, now energy of the system becomes Q plus U1 now. Again on this I am doing W amount of work. What I am doing? W amount of work. So therefore the total energy become U2. The total energy of system become U2. So now what is mean by U2 here? U2 is equals to Q plus U1 plus W. Right now? So if I bring that U1 to this side, what happens? U2 minus U1 is equals to Q plus W it becomes. So this is U2 minus U1, something like final minus initial. Like if I change from here to here, this is a V1, V2 if I write. So what is the difference if I ask? What you will say? V2 minus V1, right now? So V2 minus V1 you will say. Similar to that, here U2 minus U1 now. So you can say this as change in the energy. Which energy? Internal energy of the system. See, every chemical substance is associated with some energy. See, we are standing like this or we are living like this means anything existing in the nature means, yeah, that particular substance has some energy internally. How that energy comes? From its microscopic energy levels. It means microscopic energy levels means, see, that let us say oxygen or oxygen molecule or whatever it is, like there is a molecule like this, A molecule is there. So this bond get vibrates and these particles move here and there. So that is what the total energy, the internal energy of the system is calculated as its kinetic energy and its potential energy, or we can say its bond energies. See, ikkada bond undi kada, so the energy of that bond, and these molecules are moving here and there and molecules keep on rotating. So it means its rotational energy and its vibrational energy, because molecules will vibrate here and there, vibrational energy. So all types of energies can be added to calculate this internal energy. Okay, U1. So like that you are going to get internal energy U1 after supplying Q amount of heat, W amount of work, it becoming U2. So that whatever the internal energy change is there na, U2 minus U1, I am indicating with as delta U, which is equals to Q plus W. Okay, what is it? Delta U is equals to Q plus W. So you can also write this for small changes as dQ plus dW, which is equals to du, dW equals to du. Okay, that's it. This is the first law of thermodynamics. Okay, so what is this du means? Internal energy change. This is internal energy change, internal energy change, and this is called heat change. Heat, whatever the heat we supplied or taken out from the system, that is dQ. Okay, and this is called work done. What is that called? Work done. So what do we mean by work done? See, in physics you might have came across something. I will tell you here. So in physics you have must came across this thing. Work is equals to force into displacement. Work means what? Force into displacement. You have studied this, I hope. Okay, if not, you just listen to me. What I am saying, work can be defined as force into displacement. Okay, it is simple ma. See, there is a substance here in the hand. So now I am using some force and displacing the substance. So this is what the work. It means I need to take this stone from here to, from this one point to second point. Now what I need to do? I need to use some force on it to displace from here to there, right now. So force into displacement is called work. In the simple definition you can understand in that way. Okay, force into displacement. Now in the place of force I can write force per unit area is called pressure. What I am writing? Force per unit area is called pressure. Okay, now from this force is equals to pressure into area. Okay, so in the place of force I am writing pressure into area into this displacement. So displacement is nothing but change in the position now, from here to here if it is moving, the change in the position. So change in the length only now. So I am saying the change in the length, like L2 minus L1 we will say now. So that is indicated with DL. DL means what? Change in that length or displacement. Okay, so that is written as DL here. Okay, so now we know volume of a cube or volume of a container, how we will say? Length into breadth into height. If I say length into breadth only, that is becoming area. Area into height we will write. Okay, but here height or whatever the length is changing. So something changing into this number becomes completely changes, right now. So length into area into length becomes volume. So it is changing. So change in volume, that is dV I am writing, or delta V you can represent. Anything is fine here, dV. So dV represents what? Change in volume. Why that change in volume is written? Because area multiplied with length. Because volume means length into breadth into height we are taking now. So here length into breadth as area into height, that is the displacement here. So all three L into B into H only, no? That's why I am writing it as dV. Okay, change in volume. Change in length is there, displacement is there, that's why I am writing change in volume. Hope it is clear up to here. And that is multiplied with pressure. So P dV, this is equals to W. So work done is equals to P dV. Pressure into, like pressure will be remain same here, pressure into change in volume. So this is called work done. Okay, and now in chemistry we will be using a negative symbol over here. Okay, why this negative symbol? Because for example, see, I am writing a container here. This is a container. So container having volume up to here, this is the volume of the container. Okay, now if I say volume is expanding, if it is moving up to here, so this is the difference now. Okay, difference. Like that, when it is undergoing expansion or compression, in order to see that the container is undergoing expansion. So container is undergoing expansion means that is called as work done by the system in chemistry. What is that name? Work done by the system in chemistry. Okay, so in order to indicate that is work done by the system, we are using the negative symbol over here. So what is the final formula of work done? W equals to minus P dV. So what is the use of this minus symbol here? It explains that is work is done by the system. If work is negative, that is work done by the system annattu. ఓకే, అదే వర్క్ పాజిటివ్ వాల్యూ వచ్చిందనుకో, ఇక్కడ పాజిటివ్ వచ్చిందనుకో, అప్పుడు ఏమనాలి? వర్క్ ఈజ్ డన్ ఆన్ ది సిస్టమ్ అనాలి. ఓకే, ఐ హోప్ అప్ టు హియర్ ఇట్ ఈస్ క్లియర్. ఓకే, సో వాట్ ఎవర్ ద ఫార్ములాస్ వీ గాట్ యూ రైట్ ఓవర్ హియర్. సి du ఈక్వల్స్ టు dq ప్లస్ dw అని ఒకటి వచ్చింది. ఓకే, ఎనీవేస్ ఇఫ్ యు ఆర్ still having confusion on this, please watch it once again, or we will discuss about this once you come here. Okay, because I will show you some demonstration also, so that you can feel more clear, okay, in the offline session after this bridge course. Okay, right. So now let us see one or two questions on this. Once read this question. A system does 100 joules of work on surroundings by absorbing 150 joules of heat. Let us say this is a system. Okay, so system does, it means work is done by the system. So it is doing some work. How much work it is doing? 100 joules of work. Okay, so work system does 100 joules of work on its surroundings. That means I told you there is something called system, and the other part whatever it is there, that is called surrounding. They are saying work is done by the system on surroundings. It means work should be negative. Work done by the system now, so work should be negative, I told you. That's why we have taken formula as W equals to minus P dV in the previous line. Okay, now here you can observe the statement surroundings by absorbing 150 joules of heat. So how much energy of heat is applied absorbed here? That is heat absorbed. Q is equals to 150. So this much amount of heat is given into the system now. Yeah, so this is the amount given, this is the amount of work done. Okay, what is the formula? We have du, because they are asking change in internal energy. What is the change in internal energy? So change in internal energy is equals to dq plus dw we have taken. So dq is how much we got? Plus 150. Okay, plus 150. And how much amount of work it is doing? 100. So that is work done by the system, now that's why this negative. So finally, what is the work internal energy change? 150 plus minus 100. So that is plus 50. So this could be your final answer for the discussion, 50 joules. So our second option will be perfect for the discussion. Okay, అర్థమైందా? కాకపోతే మళ్ళీ ఇంకొకసారి చూడండి, change in internal energy they are asking, du they are asking. What I should do? dq plus dw. From where I am taking this? This is from first law. Okay, so dq, it means what? Heat changed, like heat absorbed or heat released. How much value they given? They said heat is absorbed. How much amount it is? 150 joules. Okay, you write absorbed now, so plus 150. If it is released, it is minus 150. Since they are saying absorbed, you write plus 150 joules. And then next, work is done by the system on the surroundings. So system is doing some work, that is work done by the system means negative, work done on the system means positive. So work is done by the system now, that's why it is negative value over here. So 150 minus 100. Okay, how much it is? Plus 50. Okay, hope this is clear. Yeah, let me give you a question. Please tell me what is its answer in the comment box. Okay, comment lo cheppandi దీనికి ఆన్సర్ ఏంటో. Okay, a system provided with 200 joules of heat, and does work of 100 joules. Then calculate internal energy change. Okay, like this we can expect. Once again, what I told you, a system provided with 200 joules of heat. It means this is a system. To this system, how much energy I am providing? 200 joules of heat is provided. Yes, 200 joules of heat is provided. And that system is doing a work of how much? 100 joules. It means it is doing a work of 100 joules. So this is supplied, this is removed. You can observe. This is supplied, this is removed. So you should take this as minus, this as plus. That's it. So change in internal energy will be equals to du is equals to dq plus dw. dq is plus 200 and dw is minus 100. That's it. So your answer should be 100 joules. Okay, like this you can solve. Okay, one more question I am giving for you. Do it directly, straightforward question I am giving you. You just tell me your answer. Okay, a system absorbs 50 joules of heat and does 25 joules of work is done on the system. Calculate internal energy change. Very simple, just follow same steps, but observe what I am mentioned here. System is absorbing, it is 50 joules of heat is supplied to the system, and the next 150 joules of work is done on the system. Here work is also done on the system, heat is also given to the system. Both are added into the system only. So both values should be positive. Both should be taken in the positive values. Like 50 plus 25, that means 75 joules is your answer. Okay, anta simple ga untayi amma questions. Ikkada concept ardham chesukodam important. Okay, so because solving this addition subtraction everyone can do, but making it in the correct way is important thing. Okay, taking the negative symbol, positive symbol is a important thing in the discussion. Okay, right. So anyone in the comment box having any confusions? Yeah, if no confusions, yeah, we will move forward. Okay, one question for you. Only solve this question, the one which is present on the board. So these are the PYQ questions of JEE exams or NEET exams. You can see a system is provided with 50 joules of heat. I am explaining here. System is provided with 50 joules of heat and work done on the system is 100 joules. The same way that we have discussed the last question which I given as a homework. Okay, once again, a system is provided with 50 joules of heat. How much energy is provided to the system? 50 joules. Then work done on the system. So if this is a system, it is provided with 50 joules of heat and also work is done on the system only. So both are provided into the system now. So now tell me what is its internal energy change out of these 4 options. Okay, now I am not going to give you the exact answer. You have to explain or give me your answer in the chat box. Okay, in the comment box you mention what will be your answer for this question. Okay, right. So this is about the discussion for today. So the remaining things, like there are few more little things I just wanted to convey from thermodynamics. We will be discussing them in the upcoming session. Okay, right. So then later we will go with some chemical kinetics portion, electrochemistry portion. Okay, every chapter we will try to touch it once at least, so that when you come here, when you listen to us, you won't feel it is new to you and it is connecting to your class 10 syllabus. Okay, so this is the main motto of this bridge course. Okay, so thanks for watching. Stay connected with our NEET World YouTube channel. Thank you. You can solve some questions on this. Okay, right.